Greetings everyone, I'm Harin Maita from 5th SEM of BTech ICT and I'm making this video for the submission of learning by doing assignment in ML. So in this assignment we will look into some online simulation tools through which we can visualize the ML algorithms. So first one in this list is linear regression. So we will start by I'm using someone's work to show you what is linear regression first. So as it says, linear regression is technique of determining statistical relationship between two variables or more variables. So it has something called hypothesis. Hypothesis is something that tells us how these two things are connected or these two variables are connected. In our case, it is at theta of x is equal to theta 0 plus theta 1 into x. This is the equation of line, as you can see here. And here is an example. Now we have something called cost function. The cost function is the error uh, between our predicted value and the actual value. Congratulations, Diviraj. Here, M means the total number of examples or the observations that we have. Uh, to visualize this, you can there is something I would like to show you that is here. So this is the predicted line that is being predicted by our equation y is equal to mx plus c or the hypothesis, and these are the actual observations. So this line, the green lines that you see here, the average of these lines, the sum squared average is the cost function. Now, in order to reduce this cost, we have different algorithms. One of such algorithms is gradient descent. So, in gradient descent, let me show you here. We have the thetas or theta 1, theta 2, theta 0. They are called weights. So we try to find the best weights or the what we can say using the equation is like we want the best m and best c such that our actual value and the predicted value are as near as possible to each other. So here is the equation, the gradient descent. So we have theta 0 is equal to theta 0, the previous value of theta 0 minus alpha divided by m. M is the sample, total number of observations. Alpha is a scalar. So we will talk about alpha in a bit. And then we do the derivation of cost function with respect to theta 0. So what alpha is the learning rate. It it is a scalar factor by which the new alpha gets downgraded, or should I say changed or smalled. I'll show you in the simulation part. So that was that about the linear regression. See, here is the alpha. The minimum alpha, the theta minimum is here, and this function is the cost function of theta. Uh, the most of the work is not of use anymore now because I want to show the simulation part. So here is the what I was telling about the alpha. The alpha controls these jumps from here to here, here to here, here to here. Alpha defines them. Most of and we can see these are constants actually. Yeah, I'll show. This is derivation and stuff. So this is what alpha does. By using alpha, we are trying to achieve the best fit line. Yeah. Now on to the simulation part. Let's go. Here. So this is the site ML Addict. Good site, I believe. Addicted to people addicted to ML. So let me show you the simulation part. Over here, we will have the cost function and iterations. So this will show the graph. Uh, this graph. It will show this graph, or precisely should I say the dotted values that we have here. And over here, we will put the x and y values. So here is the equation that we have, and here is the value of alpha. You can see this is constant. The max value is, I believe, 0.9. Yep, 0.9 I meant. So let's just leave it to be 0.5. we will see the parameters of theta. We will change these values once. Okay, so now let's put some values in here. So we have a y here and x here. Now let's start putting some values. Let's put one here, 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 here. I'm gonna make a cluster maybe. Uh, mm, Consider them outliers. I think this would be much. Now we will go one step forward. So hmm, we would see the first line that we see here, not this one, the one that comes in the animation. Yeah, this one, something like that. And it will go up or near these values like we are seeing here. So we will use first step. Let's just keep it one. Wait, let's just use it. Damn it. Default. Yep. So here, mm, boom. And hey, come on now, dude. What happened? Now see, it gives the calculation part. Now, if I click again, see, the first cost function gave us value something around 70. Yep, 70.48. And the next one would be below it. We will see after the line is not here, by the way. Quickly. See, the line is here now. Now, where is the cost function? But yeah, see, each time we might deviate from the value. See, but our cost function is pretty small, so that's why we're taking way more iterations. And this is we are doing in stepwise in iteration. So this is our epoch. These are just steps which are changing here. So that's for that actually. And if we click again, we now would have another one. See, now for the third iteration, we have 4 steps again, and it would come somewhere around here. See, now this is the maximum theta. We have reached the global minima, or should I say, we have reached this position where theta minimum resides. Okay, now we will change the learning rate. Man, I should have a reset. Oh boy, see, the line is gone. Now we have to reset it again. This is tiresome. And maybe I should have used the Python code. This time we will use, you know, let's go. We will use theta to be. Hmm, what this would do? Maybe we may deviate. See, we are deviating. Oh, so we are printing from the other side, from here. So this is what happened when you have too high of a theta. Let's just try that. Well, the cost turned out to be 0 and we can't see the line. So I guess it's negative.